Hi everyone, today I'm very pleased to share our CVPR 2023 paper, QuantArt, Quantizing Image Style Transfer Towards High Visual Fidelity. My name is Siyu Huang, I'm from Harvard University. The co-authors of this paper come from Harvard, University of Rochester, and Boston College. So in this work, we propose to enhance the visual quality of image style transfer algorithms with vector quantization modules. As shown in the slide, it's a standard autoencoder-based neural style transfer framework. The generated image shows some artifacts in textures. When we humans look at this image, we will immediately realize that it's not a real artwork. This work proposes to use vector quantization modules to enhance the visual quality. You can see that most of the artifacts can be removed in the generated image by using vector quantization. So we will discuss the principles behind this method in the following talk. In experiments, our framework can generate high-quality images for different style transfer settings without domain-specific tuning. So neural style transfer problem aims to transfer a content image into the style of a given style image. We use a neural network to extract and fuse the information of content and style images. Then we decode the features into an output image. Although existing neural style transfer methods have shown a good performance in transferring the image styles while preserving the content information, the visual quality of generated images cannot be guaranteed. Here we have surveyed many benchmark arbitrary style transfer methods from 2016 to 2022. The methods produce reasonable generations according to content and style images, but the visual quality of them are not very high. If we humans look at these images, we could easily recognize that these images are not real artworks. This is because previous style transfer methods only consider two fidelity terms as their training and evaluation criteria. The first term is the content fidelity. It ensures the generation preserves the content information in the content image. The second term is the style fidelity. It ensures the generation preserves the style information in the style image. However, we propose that there should be a third evaluation dimension, the visual fidelity term. So the generated images should be closer to the real artwork distribution. A neural style transfer algorithm should achieve a good performance between these three fidelity terms. However, it's a very challenging problem to push the generation towards the real artwork distribution. So in this work, we consider this problem in the latent space of generative models. We embed the artwork image dataset into a latent space, where we call it the style space. Then we apply a clustering algorithm to the style space. We will get clusters of the artworks. If a generated image is closer to the clusters or the centroids of the clusters, then the generation will be closer to the artwork distribution, so it has a higher visual fidelity. To push the generation towards the centroids, we propose to adopt a machine learning tool called vector quantization. In vector quantization, we have a generation feature Z as the input. Then we find its nearest neighbor code in the pre-constructed codebook and replace Z with the nearest code in the codebook. So this is vector quantization, very simple yet effective. The codebook here corresponds to the centroids in the above style space. By replacing latent features with the codes, we actually push the features towards the centroids, which is the real artwork distribution. So here we apply some tricks to make VQ to be differentiable. So the codebook can be learned jointly with the whole neural style transfer framework. So the codebook could be more effective than a manually designed codebook. We experiment our method on the most common style transfer framework, the autoencoder-based framework. By adding VQ modules after the encoded features, the generation has a significantly better visual fidelity. This is because VQ actually pushes the features towards the real artwork distribution. To evaluate the visual fidelity of our method, we propose a user study called Artistic Turing Test. We ask each user 20 questions, and for each question, we show 2 images. One image is a real artwork. Another image is generated by our method according to the style of the real artwork. Here I will show 2 examples to you. Could you tell me which one is a real artwork in this slide? You have 5 seconds to think of it. The answer is the right one is the real artwork, painted in 1650. The left one is our generation, generated according to the left photo and the style of the real artwork. Here we have one more example. Could you tell me which one is a real artwork? So the left one is a real artwork, and the right one is our generation. If you'd like to see more examples, please scan the QR code here. And in our user study, we distributed this study to 70 users, and each user answered 20 questions. The figure here shows the statistical result of the user study. The average correct answer is only 10.31, which is nearly the random guess result. It demonstrates that our method can generate images with a high visual fidelity. We further compare this generation to the generations of the state-of-the-art methods. All the methods show reasonable style transfer results, but our result has a significantly better visual fidelity. So our framework also supports a controllable generation, where users can easily specify the weights of different fidelity terms as some values between 0 and 1. As shown in the right figure, users could generate many images for one input example. So they could pick up their preferred generations by themselves. Like they would prefer higher style fidelity, higher visual fidelity, or just higher content fidelity. Since our method is simple and effective, we could apply it to more style transfer problems in addition to the photo to artwork transfer examples shown before. So we could transfer a photo to the style of another realistic photo, and this task is called photorealistic style transfer in the literature. We could also transfer an artwork to the style of another artwork. We could also render a realistic photo from an artwork. Please check our paper if you'd like to see more examples. Thank you for listening.